All right, so 1-6C is solving rational and absolute value equations. Like I said, this is mostly a review, which is the good thing. It's nowhere near as complicated as 1-6B, okay? So in the first part, we start with the rational equations. These are the ones that have fractions, okay? Most of the time they have fractions that have variables in the denominator. We find the least common denominator, we multiply each term by it, we cancel out the denominator, and then we check for extraneous roots on these. Remember, this is where we have to plug that denominator back in and make sure it's not going to give me 0 at the end, okay? The difference between what we did before and now is that these are just like a little bit more amped up as far as the numerators go. You might be factoring more, you might be using the quadratic formula, stuff like that, okay? So we start with those examples. Example 1 says 4x plus 3 over 4 minus 2x over x plus 1 equals x. So what am I going to do here? What's the least common denominator?
4 times x.
Good. 4 times x plus 1. So I'm going to multiply everything times 4 and x plus 1. So I'm going to do this long step once, but then I won't repeat it after this. This is 4 times x plus 1 over 1 times 4x plus 3 over 4 minus 4 times x plus 1 over 1 times 2x over x plus 1 equals 4x plus 1 times x. So if we do that step correctly, if we've picked the right least common denominator, then the bottom should cancel. 4 cancels with this one, x plus 1 cancels with this one, and there was none on the last one. So now we're multiplying, and now we're multiplying probably binomials instead of just a single number. So I've got to multiply this out, okay, x plus 1 times 4x plus 3 minus, this is just 4 times 2x equals, and I get 4, I'm going to move the x to the front so it's easier, 4x times x plus 1. So I multiplied everything by my least common denominator, and I canceled from the bottom the ones that needed to cancel out. And now I have to multiply out what's left. So the first one is a binomial times a binomial. I'm going to FOIL this out. 4x squared plus 3x plus 4x plus 3, which is 4x squared plus 7x plus 3. Minus 4 times 2, which is negative 8x. Minus 4 times 2x, which is negative 8x. Equals, distribute here, 4x squared plus 4x. Now, as soon as you see the x squareds and the x's, it's your hint that you're probably going to either have to factor this or do something with that higher exponent. So I'm going to subtract and move everything to one side. Subtract the 4x. And I get lucky this time. The x squareds cancel. I get 3x. Well, here, let me combine this first. This would be negative x. So negative x minus 4x is negative 5x plus 3 equals 0. 3 would equal 5x, and x would equal 3/5. Now I've just got to go back up to the beginning and see, can I plug 3/5 into my denominators? The first one doesn't have a variable. The second one, if I plug 3/5 in there, does that give me a 0? It does not, which means I get to keep it. Yep.
Another reason you did after you multiplied the common denominators, that step underneath.
Yep, this one.
What canceled?
So the 4 canceled that one.
The one above, yeah. Or so.
So I multiplied these two out, right? And the 4's cancel.
Yeah.
I multiply this by this, and the x minus 1 or x plus 1's cancel.
Mm-hmm.
And then I multiply that times that. Yeah, thank God.
Yeah, we call it first thing in the morning.
Thank you. There was like a weird clicking, like something was trying to like trip, so, but now thank God.
That's weird. This room didn't have lights yesterday.
Oh, really?
All rooms had lights. This one did not have any lights at all.
Well, isn't that special?
Yeah.
Yeah.
Just like us. Morning, everybody. I'm sorry.
We had no AC this morning, so be glad you were second.
Okay,
You're good?
Yeah.
Okay. All right, so 2, what would I have to multiply everything by?
X minus 4.
X minus 4. So this is going to cancel, and I get just x. X minus 4 is going to cancel again. I just get 4. And then 4 times x minus 4. So I get x equals 4 plus 4x minus 16. Combine my like terms. 4x minus 12. Subtract the 4x. Negative 3x equals negative 12. Divide by negative 3, and x equals 4. Check to see if you can plug that back in. Can I take a 4 and plug it back into both of these? No, I can't plug it into either of them. This is a no solution. So I think it's a D&E on WebAssign. Okay.
Why is there no solution?
Because you can't use a 4 in the denominator in the beginning, right? It would make that denominator 0, and we can't divide by 0. You're welcome.
Let's say that the denominator wasn't 0, but does it have to like in the last lesson kind of equal like a certain
No, I'm not checking all the way through. Like I mean, you can to plug it in all the way and check, but really we're just checking for an extraneous root, which is just the denominator, checking to see if it would make it undefined. Yeah. If we wanted to check to see if this was a right answer, then we'd have to plug it into all of them and see if the left equaled the right.
But normally it'll be a right answer.
I mean, hopefully if your work's right. Yeah. If you had the time to check, obviously you could check it, yeah. All right, number 3. What's my least common denominator? Well, first I got to do what? Factor this x plus 2, x minus 2. Now, what's my least common denominator? X plus 2, x minus 2. So from the first one, the x minus 2 is going to go away, but the x plus 2 stays. From the second one, the x plus 2 goes away, x minus 2 stays. And the last one, both of them cancel out. So I get 3 times x plus 2 plus 1 times x minus 2 equals 12. This would be 3x plus 6 plus x minus 2 equals 12. 3x and x is 4x. Positive 6, negative 2, positive 4. 4x equals 8. Divide by 4. X equals 2. Can I use 2?
No.
Nope. Back to again, no solution. So be really careful on those because it looks like it's good, right? It looks like, oh, I got to a nice number, but I have to check. Yeah.
But isn't it, if you plug 2 into 2 plus 2, that wouldn't equal?
So into this one, it's fine. But as soon as it goes into one of this or to this, if it doesn't work for one of them, it's a no.
Oh, okay.
Yep. Good question. Not both. It has to work. If it can't work for any of them, it's a no.
Wait, so how is this different from what we learned before?
It's just that sometimes you're going to have a more complicated numerator. That's all. The process is exactly the same. Questions? Okay. So number 4. All of those denominators can be factored, right? So I'm going to go one by one. How do I factor x squared plus x minus 2?
X minus 1.
Minus 1 plus 2. Good. How about x squared minus 1? X plus 1, x minus 1. 2x squared plus 6x plus 4. So let's do our first and last. 8 factors of 8 that sum to 6. 2 and 4. Replace the middle term with it. 2x squared plus 2x plus 4x plus 4. Factor by grouping. X plus 1. 2x plus 4. I could have also said from there, take out a 2. So I could have done that from here too, right? I could have done 2x squared plus 3x plus 2. And I would have gotten 2x plus 2, x plus 1. So if you catch it there, it makes it easier. Okay, you could do it either way. So that's that whole denominator. 2x x plus 2, x plus 1. Okay, so now what's my least common denominator?
Two.
2,
X plus two.
x plus 2,
X plus one.
x plus 1,
X minus
x minus 1. Yay! 4 things.
one.
Remember how we just said how is this different from before? Yeah. Okay, so for the first one, the x minus 1 cancels. The x plus 2 cancels. I'm left with the 2 and the x plus 1. The second one, the x plus 1 and the x minus 1 cancel. I'm left with the 2 and the x plus 2. And the third one, the 2 cancels, the x plus 2 cancels, the x plus 1 cancels, and I'm left with x minus 1. So not so bad, right? It looked like it was going to be bad. It's not so bad. So I get 3 times 2 times x plus 1, which is 6 times x plus 1, minus, don't forget that's a minus in between, 1 times 2 times x plus 2, which is 2 times x plus 2, equals 7 times x minus 1. Distribute. Combine the like terms. Subtract the 4x. Add the 7. Divide by 3. And x is 3. Check it. Can it plug into this one? Yes, this one. Yes, this, yes, this, yes, this, yes, this, yes. Which means we actually get to keep that answer. X equals 3.
So we're just making sure that it can go into the,
And not give you a 0 in the bottom.
so if we get that, then it's the correct answer.
Correct. Well, it's not necessarily, I mean, we're hoping it's correct, right? We're not checking. We're just checking to make sure it's not an extraneous
We're
root.
not doing what we did like last time of checking it all.
Right. Because this is actually like, it is right, but sometimes it's an extraneous root, so it doesn't work. So that's what it is. Does that make sense?
Yeah.
Okay.
If there was an x minus 3 in there.
Then
it
it's
would-
no solution. Yep. All right. How about you do 5? I'll give you a minute or two to do 5. All right, so least common, first I factored and I got x times x plus 1 on that last one. Least common denominator is x times x plus 1, multiplied both, all of them by it. From the first one, the x plus 1 cancels, so I multiply by x. The second one, the x cancels, I multiply by x plus 1. And the last one, they both canceled. Distributed out, and I got 4x squared plus 3x plus 2x plus 2 equals 1. Combine my like terms, 4x squared plus 5x plus 2 equals 1. Subtract that 1 as soon as I know I'm going to have to factor. 4x squared plus 5x plus 1 equals 0. I did first and last. I got 4 times 1, which is 4. Factors of 4 that sum to 5 are 1 and 4. plugged them in. I got 4x squared plus 1x plus 4x plus 1. Factor by grouping. And you get 4x plus 1 and x plus 1. Solve them, negative 1/4 and negative 1. When I check the negative 1, it doesn't work. So I rule it out. The negative 1/4 is fine, and that's the answer you keep. Yes. Sure. Yeah, you just can't have 0. 0 is undefined. Yep. Question was, can you have a negative in the denominator? Absolutely. Not under the root, right? That was a problem with the root ones because we were not dealing with i's. But in the denominator, sure. Yep.
What's the circumstance where we have to equal the fractions to 0 and do that? Because we haven't been doing that, or sorry, not the fractions. We have to equal the change parentheses to 0 because we haven't been doing that in the other problems.
Oh, just because there was no factoring before. So as soon as you factor it, you're going to set every term equal to 0.
Okay.
So like we didn't factor in the last one.
Okay.
Yeah. All right, 6. So notice I've got technically a 6 over 1, a 6 to the 2x minus 3, and a 6 to the 2x minus 3 squared. This is already factored. I don't have to factor it, but what's my least common denominator? 2x minus 3 squared. Okay? So it's got to be the highest exponent. Think about if it was x and x squared, we'd make it x squared. It's got to be the highest exponent, which is squared. So I'd have to multiply 6 times 2x minus 3 squared equals 1 of the 2x minus 3's would cancel. 7 times 2x minus 3 plus both of them cancel. There we get lucky. Great. Then I would have to FOIL this out. So remember our shortcut for the squares works. And it would be the first one squared, so 4x squared. The last one squared, so positive 9. And then double the product, so negative 6x times 2, which is negative 12x. Equals, distribute the 7, 14x minus 21 plus 3, distribute the 6. Negative 23 plus 1 was negative 18. Get everything to one side. Okay, can I make that easier on myself? They're all even, right? So divide by 2. No, because I can divide everything by 2 because it's equal to 0. If I divide everything by 2, it goes away. Yeah. So I could have put the 2 on the outside, but then I ended up dividing by it anyways. All right, so 12 times 36. $432. Factors of 432 that sum to, I'm going to cheat and get my calculator because of time. 432 that sum to 43. $12 and 36. Uh, 672. $9 and 48. There it is. No? Okay, there's 16 and 72. They would both be negative. So I get 12x squared minus 16x minus 27x plus 36. I promise they're not that bad without a calculator. Divide, and I'd get 4x, 3x minus 4, negative 9, 4x minus 4, 3x, sorry, minus 4 equals 0. 3x minus 4 and 4x minus 9. Set these each equal to 0, and I get 4/3 and 9/4. If you want to check here, like, so I could have just take 2x minus 3 and said this can't equal 0. 2x can't equal 3, and x can't equal 3/2. So that's what I would have ruled out, which means both of these are fine. So it's funny, this is the way, like Ms. Ferrer, I think, worked it out. I actually would look at this, and this is a great way to practice your substitution. So from here, because there's a different way to do this, 2x. Plus 3. Okay. Let's look at it from there, right? And this is a good segue into your review. Do you see that one thing, the same thing in the parentheses is there, but one's raised to the second and one's raised to the first, right? Do you remember when we did the substitution with A? We did it with that kind of stuff. So I would get everything to one side. I would do 6, 2x minus 3 squared minus 7, 2x minus 3 equals 0. So I'm moving everything to one side to set up my factoring. Then I'm going to say, okay, this and this are the same expression. The first is just squared. So I can say, let's make that A. A becomes 2x minus 3. Remember, the 1 in the middle becomes my A. So then this becomes 6a squared minus 7a minus 3. A lot easier than 24. What was that? 24 and, I don't even know, 36, right? A lot easier. Now I factor this, so this would be 6 times negative 3, negative 18. Factors of negative 18, that sum to negative 7, negative 9 and positive 2. 6a squared minus 9a plus 7a minus 3. Sorry? Plus 2a, thank you. The math in my head. This becomes 3a, 2a minus 3, 1, 2a minus 3, and I get 2a minus 3 and 3a plus 1. So 3/2 and negative 1/3. Now those are your a's, right? Not your x values. So at the end, I have to take these and plug them back in. So this equals a. And I get 2x minus 3 equals 3/2. And negative 1/3 equals 2x minus 3. Add the 3, which would be 6/2. Divide by 2. Or multiply by 1/2, 9/4. Add the 3, or the 9/3 there. 8/3 equals 2x. Divide by 2, or multiply by 1/2. And there's my 4/3. So in my opinion, just because the numbers got so big on the left, it's easier to do the one on the right. But if you're not great at that substitution part, you can always go back the other way. None of the numbers are that big on your quiz that they're going to be that painful for the factoring, okay? But the process, remember the substitution process because you can see it. And then test-wise, the rational equations will come back. Yeah. I don't think so. So Madison just asked if you can have a calculator. If you can, it will be put on the lockdown browser for you, so you won't have a separate one. Huh? Right, so they would have to have the same thing. So Miss Ferry's not here this morning, but I'll ask what they're doing, and then I'll let you guys know. Yep. Yeah. Yeah. Okay, last part of this section is absolute value equations. Again, something that hopefully we remember, and these aren't too complicated just yet. Absolute value equations, okay, we're going to see absolute value on our equations. We're going to remove the absolute value bars, by setting the equations equal to the original number and the opposite of the original number. Because if I had absolute value of x equals 2, technically that x could be a positive 2 or a negative 2, and when I find the absolute value, it's 2, right? So these solutions must also be checked, okay? And there's a special case, like the absolute value can never have can never be equal to a negative. So if I said this, my answer is no solution from the get-go. There's no answer that can by itself, when the absolute value is by itself, come out as a negative number. Okay, so those you catch, you save yourself tons of time. All right, number 7. And we'd say, okay, it's equal to a positive number, so I can do this. I'm going to take what's inside 2x plus 1. I'm going to set it equal to positive 5, and then I'm going to repeat that again, negative 5. So the biggest mistake people tend to do with absolute value is change the sign inside. We don't change the sign inside on an expression. Only if we plug in a number and then we simplify it to a number and then we take it out, we change the sign. But when you're solving these, you keep that as 2x plus 1. Even if it was a 2x minus 1 inside, we would keep it as 2x minus 1. You just change what it's equal to. Subtract the 1, 2x equals 4, divide by 2, and x equals 2. That's one answer. Subtract the 1, 2x equals negative 6, divide by 2, and x equals negative 3. Make sure we did this right. Take the 2, plug it in. Absolute value of 2 times 2 plus 1 equals 5. Absolute value of 2 times negative 3 plus 1 equals 5. 4 plus 1, and absolute value is 5. Absolute value of 5 is 5. That works. Absolute value of negative 6 plus 1. Absolute value of negative 5, which is 5, and that one works.
So even as a negative, answer, you just can't have it as, after the equal sign?
Correct. It can't say absolute value equals a negative, but your actual x value can certainly be negative. Yep.
So the absolute value just means you keep the same,
It makes, it's always positive.
Oh, sorry, positive.
Always positive. So whatever's in absolute value, whatever number's in absolute value, always comes out as the positive version of that number. So what do I say about number 8? No solution. Yay, we love those. No work involved. If you had worked it out, you would find that when you plug it back in, it doesn't work. So that's why we check them. But if you can catch it from the beginning, save yourself a ton of time.
So the no solutions are just the ones that equal or negative?
Correct. And if there was something like negative 3 on the front of this, I have to wait until after I divide by negative 3. I have to wait until that absolute value is completely isolated to make that call, because that technically can be done, right? It's got to be just the absolute value on the side by itself equals a negative, and that's when it can't be done. Okay, last slide of examples. Number 9, absolute value of x squared minus 3x equals negative 4x plus 6. This is not saying that's equal to a negative number, right? I don't know anything about what x is. It could be positive, could be, so I can't rule this out yet. And normally I set it equal to positive and negative version of that number. So I'm going to set it equal to the positive, which means the original. But then I'm also going to set it equal to what happens if I multiply this by a negative 1 and get the opposite.
Positive 4x minus 6.
Good. So I also set it equal to that. Get everything to one side. Here I go with the factoring again. Factors of negative 6 that sum to positive 1. Negative 2, positive 3, 2, negative 3. I'm going to check them in a minute. Go to the right side. Subtract. X squared plus x plus 6. X this time plus, oh wait, sorry. Yay, this time we have to. Did I do that right? Plus. Oh no, I didn't subtract, I added. I was going to say, I didn't think there was a quadratic in this one. This should be minus, so this would be minus 7. Now it's negative 6, negative 1. Now I would take and plug them all back in. So when you plug back in, one of them doesn't work. Let me show you which would. I think it's the 2. Yeah. I'm just going to show you the one that doesn't work for time purposes. I think it's negative 3. So absolute value of negative 3 squared minus 3 times negative 3 equals negative 4 times negative 3 plus 6. 9 plus 9, negative 12 plus 6. Absolute value of 18 is 18. Obviously, that's not the same thing as negative 4. So just to save on time so we can start talking about your quiz, I'll tell you the other 3 work. No, that's a lie. The 2 doesn't work either. Yeah. Positive 12. One of them doesn't work. The negative 3 does work. See what happens when you rush through stuff. Okay, this ends up being 18 equals 18. That one works. It's the 2. 2 squared minus 3 times 2 equals negative 4 times 2 plus 6. 4 minus 6, negative 8 plus 6. Yeah, this is negative 2, and that becomes positive 2. That does not equal negative 2. So the 2 is the one that doesn't work. Let me double check. I think the 6 doesn't work either. Yep. So the 6 and the 2 don't work. The 1 and the negative 3 do. So I didn't plug those in, but I'm telling you, well, we did plug in the negative 3. The 1 will also work. So these absolute values you've got to check for extraneous roots, just like we did with the other ones. Yeah.
What's the instance where you have to split the things into 2? Like the first step that you did for each?
If there's absolute value bars. So the same thing's gonna happen for 10.
So we did that for all of them?
Yep, except for the second one, which was no solution.
Oh, okay.
Yeah. So now I'm going to say x squared plus 4x equals 7x plus 18. And then x squared plus 4x equals negative 7x, because I'd have to do the negative 1 times both, minus 18. Are you okay if I finish this on the video because it's the same as the last one?
Yes.
Okay, and then I'll skip to that quiz review. All right, so let's finish up this question. Here, I'd move the 7x and the 18. X squared minus 3x minus 18. Factors of negative 18 that sum to negative 3, negative 6, positive 3, and I get 6 and negative 3. On the right, add the 7x and the 18, and I get x squared plus 11x plus 18. Factors of positive 18 that sum to 11, 2, and 9. Negative 2, negative 9. Now we check. So absolute value of 6 squared plus 4 times 6 equals 7 times 6 plus 18. Absolute value of negative 3 squared plus 4 times negative 3 equals 7 times negative 3 plus 18. Let's start here. 36 plus 24, oops, absolute value. 42 plus 18, absolute value. And 60 equals 60. So that one works. Go to the next one. Absolute value of 9 minus 12, negative 21 plus 18. This gives me a negative 3. No absolute value is going to give me a negative 3. So I rule that one out. Go to the last two. absolute value, negative 2 squared plus 4 times negative 2, 7 times negative 2 plus 18, absolute value, negative 9 squared plus 4, negative 9, 7, negative 9 plus 18. So work this side out first because we can cancel it out if it's negative. Negative 14 plus 18. Okay, not negative, so now go here. 4 minus 8, absolute value of negative 4, which is 4. That one works. Now the negative 9 one. Negative 63 plus 18 is going to give me a negative 45. This cannot equal negative 45. So I rule out the negative 9 and I keep negative 2 and 6. There's only 10 questions on the review. There's only 6 questions on your quiz because a lot of them take a little bit of time, okay? The good news is it's not like multiple choice, so it's not like an all or nothing situation. I don't want anybody, I saw the looks of panic on your faces. I don't want anybody to panic. The good news is there's partial credit on these because they're open-ended, okay? But you have to be so very careful with this stuff. So this comes from the 1.6. A goes all the way, well, this is A, this is all mixed in. I'll write it on the solutions because these are polynomials. Those are the A's, and then these are the B's. Okay? But remember when we did in section A, we did polynomials of higher degree, so these could be factoring by grouping, like number 1. Greatest common factor, so this is grouping. GCF. Factoring where there's an x squared and an x squared. Okay. Same for this, or you could use your substitution there as well. You can do the substitution for the A if you wanted to make A x squared. And then this is also GCF. Don't forget your rules, like when you go to square root both sides, putting the plus and minus in front of those, okay, that happened up in that section. The crazy ones were 1/6b, so let's look at those for a second. When you're dealing with one square root, what do? Square both sides. Same thing's going to happen like for number 3, except when we square both sides, we're going to have an expression there. Remember to use that shortcut. So if I just did that first step for you, here, let me do that. Number 3. Remember, we square the first term, which would be x plus 2. We square the last term, which would be positive 1. We double the product. So 2 times 1 times square root x plus 2 would be 2 square root x plus 2. And on the right side, it's gone. Then we got to get everything to one side again, and then we square it again. So those were the fun ones, okay? That's like number 3. I think that's probably the worst one.
On the quiz, are we going to have any questions that have
Fractional exponent?
Yes.
No, we saved them.
okay.
Yeah. They're not gone. They'll come back, but not on the quiz. Yeah. The fractional, like the 2/3 and the 1/3. Yeah. All right, then 4, we square both sides. Now I'm panicking. Hang on, let me double check. Okay, and then 5, you're going to square both sides. 6, you're going to square both sides again, okay? So remember that anything with those square roots, you have to do what once you get to your answers? Plug them back in to check, okay? So be careful on those because those where you can rule something out. So that, I think once you take out the 1/3 and the 2/3, they're not as bad. Yes, we feel a little bit better about it. If I actually posted the worked out solutions to these with each question worked out. My advice is obviously to work through them all first, then check your answers so you don't give yourself a false sense of security, like you know what you're doing by checking it as you're going, okay? And then on tomorrow when you come in, you're going to get 30 minutes for the quiz, which means the first couple minutes we can kind of talk about stuff. You're going to take it in lockdown like you did last week's. You're probably, I don't think you're going to have a calculator. I'm just going to say no, and then if I surprise you tomorrow with it, it will be on lockdown, so you don't need a physical calculator. You can use notes and then hard copy for your actual problems. You guys, I'll give you a physical paper if you're in front of me. You have a question?
What are the ones where you have to check?
Any kind of square root
Okay.
has to be checked. And then now absolute value. Oh, and the denominators. But yeah, any kind of square roots. So the ones where we're factoring, as long as you're doing it right, it should be fine. There's no such thing as an extraneous root there. The extraneous root comes with
So for this quiz, it's just the
square roots. Yep.
And we have to check if it was the fourth root also.
Yeah, because technically that's like a even root.
So it's all even roots?
All even roots. Yep.
Will we have to have like printed out notes again, or will we have it on?
If you want hard, you have to have hard copy. Yeah. So print it out, but not every. You don't have to do every section. Yeah. At least there's only 2 sections in this one, I guess. Your parents are gonna kill me with your colored copy ink.
This is black and white.
Was it black and white?
Yeah.
I thought they were colored last time. Yeah. Any other questions as far as quiz goes from home? So you have 2 assignments on your to-do list for today. The first is this quiz review. Start with that. Focus on that tonight. The second is your homework, which is not technically due till Monday. So if you want, give yourself a little bit of breathing room on the 1-6C and do that for homework over the weekend. Just focus on 1-6A and B for tonight, okay? Okay, here's one of the number 17s from the homework. So the easiest way to do this is actually factor out the x minus 1 to the 1/3 and a 2x. Those are the greatest common factors. So 2x comes out and I get 2x times x minus 1 to the 1/3. That's the whole GCF. So if I take this and divide by 2x, x minus 1 to the 1/3, I'd get 7x. Plus, take this, divide it by 2x and x minus 1 to the 1/3, and I get 2x minus 1 to the 3/3. And that's why this is easier, because this becomes 1. So I get 2x, x minus 1 to the 1/3, and then we'll distribute here, 2x minus 2, and then combine my like terms. 9x minus 2. Now it's already in factored form. Here's 1, here's the other, here's the third. So I can say 2x equals 0, x minus 1 to the 1/3 equals 0, and 9x minus 2 equals 0. Divide by 2 here, x equals 0, cube root here, and it's gone, x minus 1 equals 0, so x equals 1, and 9x equals 2, x equals 2/9. And there you get all 3 of the solutions there. You'd have to plug them back into check, but all of them would be fine. So each of those would be the answer. So here's another version of that same question. This time I can take out an x minus 1 to the 1/3 and a 2x again. So I'd end up with 5x plus 3x minus 1 to the 3/3. This becomes 1. I get 2x, x minus 1 to the 1/3, and distribute here, 3x minus 3, and I get 8x minus 3. Then I set each of them equal to 0, and I get x equals 0. X minus 1 would equal the cube root of 0, which is 0. X equals 1. 8x equals 3, and x equals 3/8. 1, 2, 3 answers. In this example, if we raise it to the reciprocal, which would be 2/3, if we do it all in one step, then realize that you're taking the square root of something. So when I'm doing that, I'm also going to cube it at the end. But when I'm taking that square root, I have to do plus and minus over there. So plus and minus the square root of 25 raised to the third power is what I'm looking to do. X plus 3 equals plus and minus the square root of 25 to the third. So x plus 3 equals plus and minus 5 to the third, which means x plus 3 equals positive 5 to the third, and x plus 3 equals negative 5 to the third. X plus 3 would equal 125, x would equal 122, x plus 3 would equal negative 125, and x would equal negative 128. And those are your two solutions. Okay, this one is just like that first section. So this time I can actually take out a 1/2. X minus 1 to the 1/2. And I'd get 9x, this is gone, plus 4, take out one of the x minus 1s, and I'd get x minus 1 to the 2/2. This becomes to the first power, and I get x minus 1 to the 1/2. 9x plus, distribute this, 4x minus 4, x minus 1 to the 1/2, and I get 13x minus 4. Set each equal to 0. Square both sides here. X minus 1 would equal 0, x would equal 1. 13x would equal 4, and x would equal 4/13. So this time when I plug these back in, the 1's gonna work for both. But if I plug in 9 times 14/3, and then 13ths minus 1 to the 1/2, even if I just stopped there, if I kept going, I obviously could. But this 4/13, this would be 13/13, and I'd end up with negative 9/13 to the 1/2, which is the square root of negative 9/13, and that cannot be done. So I rule that out. The other way to do this is, remember, I can move the 4 to the other side, raise each one to the power of 2. I'd get 81x squared times x minus 1. Negative 4 times to the second power is 16. X minus 1 cubed. Then I have to expand and FOIL that one out and get everything to one side, solve it. So that gets a little bit more complicated when it's that high of a power. Okay, this one says solve and check your solutions. So I get x squared minus x minus 62, 3/2 equals 343. So if I want to get rid of the 3/2, right, raising to the 1/2, the first thing I can do is square both sides, or square and cube root, which would give me the same, so 2/3 raised to the reciprocal. Because I'm cube rooting this time, I don't have to do plus and minus. So if the bottom number's odd, I don't have to do plus and minus. If the bottom number's even, I have to. So the easiest thing here, so that I'm dealing with smaller numbers, is to cube root 343 first and then square it. So the cube root of 343 is 7. 7 squared is 49. Subtract the 49. And I get x squared minus x minus 111. That's not factorable, so I have to use the quadratic. Negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. And here matches that. It's just separated out, pulled out the 1/2. So you can actually leave it the way that it is because it won't simplify. All right, this one, we want to square both sides of the equation. I think this was Madison's. I forgot. But if you square both sides of the equation, you're going to get to here. And I believe you probably got all the way down to here. And -4 and 1. But if I plug back in -4, remember you have to check these solutions. If I plug back in -4, I end up with this over here. -4 plus 8, which is square root of 4, equals 2 minus 4, and then I get the square root of 4, which is 2, equals -2, which doesn't work. And that's why the -4 gets eliminated. All right, here's 13. So x plus 2 to the 2/3 equals 9. So again, I want to raise both sides to the 3/2. And because I'm square rooting something that was squared, I have to put a plus and minus here. So I get x plus 2 equals, and it's plus and minus the square root of 9 raised to the 3rd power. X plus 2 equals plus and minus 3 to the 3rd power. So x plus 2 equals positive 3 to the 3rd, and x plus 3 equals -3 to the 3rd. X plus 2 equals 27, x equals 25. X plus 2 equals -27, x equals -29. There's my solutions.